welcome back to the GTI Setco channel. We're coming back from holiday here, wishing everybody a happy new year in 2024. And as promised, this is another instructional video that's going to be talking about tooling imbalance. This is a white paper that I did several months ago, and I've already posted, and I will put it down in the description below so that you can read it as well. But it's all about unbalanced tooling and how it can affect the life of your spindle and spindle bearings and how it impacts it. And in this video, we're going to show you running a good tool and running a bad tool, and we're going to use VibePro 10 and this wireless sensor here, and we're going to show you exactly how we can detect what an imbalanced tool looks like and what a good tool looks like, so that we can know exactly how that's affecting our spindles. Because especially in the woodworking industry and the metalworking industry, we cannot always hear this with our ears. There's a lot of routing going on, a lot of drilling, milling, all that, or grinding in that fact, and we just don't hear the imbalance that a sensor like this and a vibration analyzer can pick up. So we're going to go out on the shop floor, we're going to show you, and then we're going to do some post-processing. We're going to show you what that looks like. So please like and subscribe as we put these videos out. We really appreciate your attention, and with no further ado, let's get out on the shop floor. Okay, we're here in the shop, and behind me we have a woodworking spindle. This is a high frequency 20,000 RPM spindle, and it's very common in the wood industry for us to not be able to hear or detect unbalanced tooling. And what I have in here now, as you can see, is a very balanced tool. And as I switch over to the other screen to show you VibePro here, you're going to be able to see what readings we get. We're well in the green here, as you can see on our ISO detectors. So a simple reading will tell us here's our 1x running peak. We've got a pretty level waveform. We are seeing some other peaks, which you will probably not see in the next video, popping up, because the unbalanced tooling is going to take away and really cover that spectrum up. But you can see everything is where it should be by ISO specs. And now we can roll, and we're going to put a bad tool into this spindle, and we're really going to show you what we see. Okay, we've now swapped the tool in this spindle, and that's what happens is, as spindle goes into tool changes, grabs a tool from the queue, and sometimes you can have a rogue tool or just overall bad tooling that you're not purchasing quality balanced tooling. And this is exactly what happens. As I switch over to the other screen here, you're going to see very quickly in the spectrum, you can see it is completely dominated by that peak right there. And that peak is our running speed peak, and it's showing us right here in yellow that by ISO specs we are far 2, 3, 4 times out of ISO spec for balance. And what that's going to do, and I can feel the energy right here with my fingers, that energy is going to transmit right into the bearings and prematurely wear out a spindle. Okay, we're back from the shop, and as you can see to my right, I have one of the spectrums that we were just looking at in the shop while the spindle was running. And we discussed how this high energy in the yellow, and that's what we bake into our software so that you don't have to think about it. If it's in the green, it's good by ISO specifications for spindles. You can switch to motors, pumps, and all those other things as well. But for this demonstration, we're talking specifically spindles. So as I said in the shop, look at that dominant peak at the 1x. And we are only running 4,000 RPM and on a 20,000 RPM spindle. And we're already over ISO specifications by quite a bit there. And if we bounce back to our good spindle, you can see, again, our software is telling us, look at the meter, we're in the green. It automatically knows by ISO specifications whether we're good, bad, or indifferent, or we have bad tooling. And this spectrum, clearly shows we've got a good tool running in our spindle, and we can test multiple tools. Now, the other nice feature with our software here is now that we can simply hit the report button, it puts our logo in there, it time date stamps it automatically, puts the photo in there, all those things, so that you don't have to think about any of that. And then you click the tap email button, it puts it in an email format for you, You don't have to do anything. It's already in a PDF here. You hit the send button and it's gone to whoever needs to look at that data, which may be Setco or GTI. You can send this data from ViPro 10 right from the iPad directly to us, and we can look at this data and tell you, whether you have an unbalanced tool, which is clearly the case here, or alignment, or a possible bearing failure. And that is all baked into our software as well. If you were to set it up to the web app, you would see that in our fault detection mode. But this is a very good demonstration of how we find imbalanced tools, and you can find your own imbalanced tools. And we hope this tool is good for you, and that's why we're doing these videos weekly. Is every week we're going to have a different subject of problems that you can find on your machine tools and your spindles. So we thank you for your attention, and please reach out to us at www.setco.com or www.gtispindle.com. Thank you for your attention.